All right, let's get right into it. We are going to look at a totally new way to teach an AI how to be a world-class software engineer. And what's really cool is how it takes two ideas that everyone thought were opposites and turns them into this incredibly powerful team. You know, this is one of the biggest questions in AI right now. And we're not just talking about writing some simple script. We're talking about diving into huge, complicated, real-world software projects and fixing those really nasty bugs. So to even see if an AI could do that, researchers needed a test, a really, really hard test. And that test is called SWE-bench. Honestly, you can think of it like the Olympics for AI coders. It is the absolute gold standard because it's not about some abstract puzzle. No. It forces the AI to parachute into a massive, unfamiliar codebase, figure out a bug report written by a human, and then write a fix that actually works. It's brutal.
Okay, so to try and conquer this challenge, the AI world kind of split into two different camps. They had totally different ideas about how to train these models. Let's call them the recipe follower and the creative chef.
So this slide really gets to the core of the whole debate. On one side, you've got the recipe follower. This is also called the agentless approach. It's super structured, it follows a fixed set of steps. Find the bug, write the code, done. It's pretty simple to train, but it's totally rigid. If a problem doesn't fit the recipe perfectly, it just fails. Then on the other side, you have the creative chef, the agentic approach. Now, this AI acts more like a real human developer. It pokes around the code, it tries stuff, it learns from its mistakes, and it changes its plan on the fly. It's way more powerful for sure, but training one from scratch is a total nightmare because it has so much freedom.
So for the longest time, it really felt like you had to pick a side. Are you team recipe follower or team creative chef? But what if that was a false choice? What if these two ideas weren't a wall separating them, but actually a bridge connecting them? Well, that's the radical idea behind this new model called Kimi-Dev.
And this quote from their research paper just nails it. The researchers basically said, hey, we've been looking at this all wrong. Instead of thinking of the simple recipe follower as the final product, they said we should think of it as a secret boot camp, a boot camp designed to build something they call skill priors. So what on earth are skill priors? Well, they're the fundamental coding muscles. Think of it like learning skills on a piano or practicing drills in a sport. They're those core, repeatable skills, like being able to pinpoint exactly where a bug is, or make a very precise change to the code, or just thinking through a problem step by step. They are the absolute building blocks you need before you can do any of the complex, creative stuff. So how'd they do it? Let's break down the first step in their plan. They had to build the world's best recipe follower, an AI that could master all these foundational skills through a really intense training program. And believe me, they did not mess around. This was a serious training program. First, they just drowned the model in real-world data from GitHub, 150 billion tokens of it. Then, they showed it examples of how expert humans think through problems. After that, they used reinforcement learning, which basically made it practice fixing bugs millions of times with a simple pass or fail grade. And finally, and this is really clever, they used a self-place system. They had one AI, the test writer, that would constantly create new problems for the other AI, the bug fixer, forcing it to get better and better. So, what was the result of this whole bootcamp? Well, their highly trained recipe follower model, Kimi-Dev, solved an amazing 60.4% of the problems on SWE-bench. And that wasn't just good. That was a new state-of-the-art score for this kind of AI. They had done it. They had forged those foundational skills. But remember, they didn't stop there. That was just the boot camp. With all those fundamental skills locked in, it was time for graduation day. It was time to unleash the creative chef. And this is where the whole thing just gets brilliant. Because the model already had these rock-solid fundamentals, it didn't need a ton of training for the creative part. Instead, they just showed it about 5,000 examples of the creative chef in action. Now, in the AI world, that is a tiny, tiny amount of data. It's kind of like teaching an Olympic gymnast how to do parkour. They're going to pick it up incredibly fast because they already have the core strength and balance.
So, did it work? You bet. The new and improved Kimi-Dev, now acting like a flexible creative chef, scored 48.6% on SWE-bench. Now, you might look at that and think, wait, that's lower than before, but look at what it's being compared to. That score puts it neck and neck with Claude 3.5 Sonnet, which is one of the most powerful, cutting-edge proprietary models in the entire world. This was the proof. Their hybrid strategy wasn't just a cool theory, it actually worked.
So why was it so incredibly effective? Well, those core skills, those skill priors. So what's the big picture lesson here? This isn't just a cool result for one AI model. This research basically gives us a whole new playbook for how to build powerful AI agents. And not just for coding, but for all sorts of other complex tasks you can imagine.
So if you're going to take one thing away from this, it should be this. That whole debate between the simple, structured approach and the flexible, creative one, it's over. The answer, it turns out, is to do both. You use that structured bootcamp to build the fundamental muscles, and that's what actually unlocks the AI's true potential to be flexible and creative.
And that leaves us with one last really interesting question to think about. Kimi-Dev proved that two methods everyone thought were competitors were actually secret partners. It really makes you wonder, what other big debates in AI are based on a false choice? And where is the next breakthrough partnership hiding in plain sight?